question 7, we're given 5 points and it asks us to find domain and range. So you need to at least tell me which one's domain and range. Some people just wrote random sets of numbers there. So at least label what's domain and what's range. So domain, we're just looking at all the possible x values. So if I look at these 1, 2, 3, 4, 5 points, okay, there's only actually 4 x values. So the domain is just going to be these x values, 3, 4, 5, and 7. Okay, you don't need to repeat that second 7. Okay, it's like someone says, what are the possible x values? Someone says 7, someone else puts their hand up, 7, another person says 7. Okay, not necessary. For the range, just looking at all the y values, and it's the same thing. So 3, 4, 5, 8, 9, and 10. Okay, just 5, 8, 9, and 10. And you do need to put these, like, they're called braces around it. There's an example of a good brace. Okay, it's sort of like a chicken with no head, no eyes. Okay, next one. Need to point at this. Okay, hopefully you know what this function looks like. From year 10, you should have some idea what it looks like. We're going to do this graphing later on in the year. But if you don't know what it looks like, you can just go to your calculator and type it into graph mode and inspect what it looks like. So I'll type this in, 3x to the power 4 minus 5. I'll draw it. Yeah, that doesn't really help me out. I'll try zoom, auto. Yeah, it looks okay. I really am interested in what's happening around here though. So I'll zoom with a box and I can arrow across and make a little box around here. Okay, press enter and it'll rezoom on that box.
So I think you zoomed into that.
I think it's because it's right on the lines there.
Okay, well it looks good now anyway. That's basically what it looks like. So if I look for my domain, I'm looking at what are the possible x values. I'm getting negative values, I'm getting positive values, I'm getting 0. I can't see any like holes or anything in this function. I can't think of an x value that I can't raise to the power 4. So I can state that my domain will be all real numbers. Okay, so domain, and there's a few different ways to write this. I can say all real numbers, or I can just say it's from negative infinity to infinity. Either notation's fine. Okay, in terms of the range, what are the possible y values? Well, I'm getting these y values here, okay, but only until this point. So I need to go back to my calculator and find what's the smallest point that I've got here. So I'll go gsolve to the minimum, and it'll show me what that minimum point is. Okay, it's minus 5. So I'd write in here that my range is y values greater than or equal to minus 5. Okay, I can write that using this other notation as well. So you got questions, just wait till the end, okay? Otherwise you'll be YouTube stars. All right, question 8 wasn't done particularly well. And probably the worst thing was that the variables weren't well defined and a lot of people didn't draw diagrams. Okay, so I read this question and it says, a heap of concrete is used to put a path around the outside of a square lawn. So I'll draw a square lawn, and there's a path going around it. And I'm not sure exactly what this path looks like at the moment, so I'll continue reading. The path is 10 centimetres thick and 1 metre wide. So around this path, okay, should be another square, okay, and this width here is 1 metre. Okay, so this is just looking like top view. You're in a helicopter looking on top of the top of the garden and the path. I don't know the dimensions of this square, so I'll put x here and define my variable. Okay, let x be the length of the square. If I was to draw this in 3D, so I've used the 1 meter width. In 3D, it looks something like this. It'd be a big block like that. In the inside here is grass, and we're making a path around it that's 10 centimeters thick. And that's another trick, that this is 10 centimeters, but we'll use it as 0.1 meters so that we have all the dimensions in the same unit, and we'll be able to calculate meters cubed as well. Okay, so I've drawn my diagram. It says write an equation and find the dimensions of the lawn. Okay, so I've used pretty much all this info apart from the fact that I'm using 5 meters cubed of concrete. So I know it's got something to do with volume. So I'll let V be the volume. And from here I can write an expression for volume. Okay, general rule for volume is area of the base times height. Okay, in our situation here, the base is actually this yellow part. Okay, that's the area that we're trying to find. Because that green part doesn't exist in concrete, we just imagine it's like a hole. So to find volume, I need to find the area of this yellow section. Okay, and then multiply that by the height of the prism. Okay, so I'll running out of space, but this is my rule. Okay, and then I'll go over to the side and just try and find what the area of the base is. Well, for area of the base, I've got that big square, okay, which includes the path and the grass. Okay, the dimensions of this big square will be, well, this is x, and then there's 1 on either side. Yeah, so x plus 2 by x plus 2. Okay, and then I'm going to take away that little square, which is just x by x. Okay, so this is everything, subtract the garden. Okay, so my formula for everything will be x plus 2 all squared minus the area of the garden, which is x squared. Okay, so that's the area of my base, which I'm going to substitute into my volume formula. Okay, so I know the volume over here is 5 meters cubed. I know the area of my base is x plus 2 all squared minus x squared, and I know the height is 0.1. Okay, so that's the equation that I need to solve to try and find the dimensions of the lawn, to try and find that side length of the lawn. It's not actually that bad to solve at all. There's lots of squares there, but when we do this expansion, okay, so inside x plus 2 all squared is x squared plus 4x plus 4. These x squared terms are actually going to cancel each other out. So we'll just have 5 equals 4x plus 4 times 0.1. And then it just turns into one of those equations similar to question 1. Okay, we can do the expansion if we want. I hope that doesn't come up. I hope that's not captured. You might be surprised. Okay, expand the 0.1 out. Okay, bring the 0.4 to the other side. Okay, and then divide all of this by 0.4, and we'll get x equals 11.5, I think is the answer. Okay, and that's the dimensions of the lawn. So it's the lawn is a square, which is 11.5, that's meters, not centimeters. That wouldn't be a very fun lawn at all if it was centimeters. Hey, this 11.5 by 11.5 meter square. Okay, that's the idea. Big tip for this one is in high school, you pretty much are only ever going to have two variables that you care about, okay, to make an equation, pretty much. So try and figure out what the two really important variables are and define them and try to use them to solve. Okay, so this is Unit 2, Topic 4. Okay, so 2G is where you want to go for more practice for these. This last one won't take very long. Question 9. A few people got this one out, which is good. They didn't set up equations formally though, which is a bit of an issue. A stall at local show can be rented for $300, so we're paying $300 regardless. Cans of soft drink cost 40 cents and are sold for $1.20. Write an equation for profit and use the equation to work out how many cans must be sold to break even. So using the same idea as the previous question, I'll think to myself, well, what are the two most important variables here? And I'll decide that I need something for profit and I need something for the number of cans sold. You might have used different letters, that's okay. Profit and number of cans sold are the two key variables that we're going to try and set an equation up for. Okay, so the trick here is we look at these cans. It costs 40 cents each. Each one's sold for $1.20. So I can calculate the profit per can will be $1.20 minus 0.4. So I'm making 80 cents per can profit. That's the idea. Okay, so my total profit is going to be 80 cents, okay, per can or per X that I sell. So imagine I sell 50 cans, X will be 50, I'll times that by 80 cents. But I need to also take away the $300 that we're spending regardless. Okay, regardless of whether we sell a can or not. Okay, so this P is found by the profit minus some expense. Okay, it works out well, profit minus expense here. Sometimes you might have to use profit equals revenue minus expense from your Year 10 business education days.
You're the man.
Okay, and you can go ahead and solve from here. Just before we solve this, what's the profit when we sell nothing? We can use this as a check. If I put X equals 0 in here, 0.80 times 0 minus 300, I'd get a profit of minus $300. Okay, I'm spending $300 to go rent a stall and sell nothing. Okay, not a very good business. What we want to find, we're going to find when the profit is nothing, okay, which is what break even means. Okay, when you make absolutely no profit, which is not good, but it's better than making negative profit and losing money. So I'll substitute 0 in here. Okay, and this is really a grade 1 or grade 2 equation to solve. You guys are going to show your parents this video and I'm going to get sacked, but it's okay. I think we get 375 cans, okay, to sell before break even. So if you think you're going to have less than 375 customers, you shouldn't open your stall because you'll just be donating money to the local show.